right. We've got block A sitting on a table. We're not taking into account any friction on the table. We have block B hanging from a pulley. Remember that the only thing that the pulley does is change the direction of the force. Okay. They both have the same mass M. We don't know what the mass is. We don't need to. We assume that the string has no mass. So our system is the two blocks and the string that is attaching to them. So what is the total mass of the system? The total mass of the system is A plus B, so our total mass is twice the mass of the block. All right. The force that accelerates A plus B is the weight. So what are the forces acting on these two blocks? Well, block B has gravity acting on it. Block A has gravity acting on it. But block A also has a support force. And those are equal and opposite, so they don't contribute to any motion. Okay. Block B puts a tension into the string equal and opposite to its weight pulling it down. All right. And that tension is constant through the string, so that is the magnitude pulling the block that way. This force is the equal and opposite to this force, which is the equal and opposite to this force. So the magnitude of this force is the same as the magnitude of this force. So the force that is accelerating the system is the weight of whom? Well, the mass of block A is not, the gravity on that one is only giving it the, only resulting in the normal force back from the table. So the only thing that is pulling block A and block B is the weight of block B. Block B is doing the pulling in this situation. What is the weight of block B? Weight is a force, it's a vector, and it is the force due to gravity. That's the definition of weight. So the weight of block B is the mass of block B times gravity. That's the only thing it can be. If we're only looking at block B, then the only force that it can do by itself is the force due to the force due to acceleration due to gravity. Block B only weighs block B. Okay. But the acceleration of these two blocks, is it going to be gravity? Is it going to be more than gravity? Is it going to be less than gravity? Now, the acceleration of these two blocks is going to be less than gravity. Because gravity is only pulling on this block. The tension in the string is only due to the force of gravity on block B. But it has to pull the mass of both block A and block B. So if our formula is that acceleration is equal to force divided by mass, And the acceleration of the system is the mass of one block divided by double the mass. This is the force. That's the force pulling downward. And this is the amount of the force that it has to pull. So the acceleration of our system will be equal to half the acceleration due to gravity. If B were allowed to fall by itself, would its acceleration be g? So if the string were cut, if we cut this string and B would be able to fall independently, wouldn't it fall at the rate of acceleration due to gravity? And that is in fact true, because gravity would be only acting on the mass of block B, not double the mass.